Is Gerald Beuchelt. He will be discussing threat modeling and sharing. Before we begin, I just want to make a full disclaimer. This session is being recorded and will be posted on the OMG website for further viewing. Gerald, whenever you're ready.
Judy, thank you very much for giving me the opportunity to speak here in this context. I would like to present today a project that we have started recently at the Object Management Group in Santa Clara last December, focusing on threat modeling. And to do that, I prepared a small presentation. This is right now, at this point in time, a fairly informal project charted out of the System Assurance Task Force. And we are currently in the process of defining what we actually want to do. At the same time, the timeline is fairly compressed and aggressive, so we expect to get a lot of done within the next couple of months, so that we may have a draft standard ready as soon as possible. With that, let me just go quickly to an overview slide here. This slide deck describes this proposal to kick off a threat modeling project in a multi-phase kind of approach. We do realize that threat modeling or threat meta modeling is a fairly complex subject, and as such we have decided to divvy up this project into multiple phases that will initially create a cyber domain platform independent model and a STIX platform specific model using the UML profile for needs. We'll go into each of those individual phases later on and describe a little more what it means. But the second step will be to expand to other platforms and create additional platforms. For example, something for Open IOC, for IODEF, for Snort rules, etc., and ultimately make sure that we have a consistent and effective threat meta model that allows us to semantically map between the different platforms that we're identifying in a consistent way. Ultimately, we do want to expand the scope of this project to non-cyber domains, meaning that initially we'll be focusing on threats to information security systems or information systems, but this can easily be expanded to non-information systems related areas. For example, there has been some interest in supply chain risks and supply chain threats, but there are obviously also other threat scenarios that could benefit from a threat meta model like this. Overall, we definitely want to be very community focused. So what we did initially, before we even proposed this project to the System Assurance Task Force at the Object Management Group, was to start looking around for existing work that has already been happening in this field. Those who have been following threat information sharing or threat sharing for a while will probably know that the structured threat information exchange language pioneered by MITRE has been around a bit and has recently been fully released. And we definitely identify STIX as one of the significant contributors to this effort, in the sense that we will lean heavily on their existing work in order to be able to create a more abstract threat meta model. There are many other standards out there beyond STIX, obviously. One of the, including Open IOC, IODEF has been around since 2007. There's the SI star framework, which is a more behavioral model, and then there are many others as well. What's really going to be important for this project is to connect to stakeholders, not only with the Object Management Group, but also outside. So this is really a call to action to anyone who has been working in the threat information sharing environment to get in touch with us and try to see whether it makes sense for them to participate. So what's the motivation in general? We definitely realize that the threats for information systems are starting to become faster and faster proliferated, and we have a need for enabling wire speed defense of our systems. So while 10 years ago it was sufficient for systems to effectively be defended at human speed, because that's how fast new threats approached, In this day and age, we see hundreds of thousands of new threats and new malware signatures each month. And as such, we have to increase the speed with which we defend those networks. Information sharing is really required in this kind of context, and for that, we need shared concepts. We really need to make sure that if we have different threat sharing environments or threat communication environments, we're still talking about the same thing. So, for example, the National Information Exchange Model, or NIM, is used by the U.S. government and other international governments in order to exchange information about subjects and in a law enforcement kind of a way. In a way, this is very relevant for a threat sharing environment, because we have in STIX the concept of a threat actor, which is effectively the person or the group that ultimately conducts cyber attacks. And making sure that there is a consistency between those two standards is critically important for enabling interoperability. In a similar way, we have snort rules, which have been around for a long time right now, that are used for configuring intrusion detection systems. And it would be very beneficial if we could use a STIX exchange that communicates a new threat from a threat source to a threat consumer, and have that automatically translated into new snort rules and then automatically be enabled. There are many protocols around today, upward of 50 at this point in time, the different languages and models. But what we really want to make sure is that we really reuse existing protocols like STIX or like IODEF or OpenIOC, and focus on the classification of threat indicators and their signatures as we do that. Ultimately, the desire is to have a better traceability also from the indicators and from the individual signatures of specific threats back to the threat actors, and then be able to identify them. And as I said before, we're definitely also looking at behavioral frameworks such as SI-STAR in order to improve the ability to identify threats or use social modeling and essentially associate them back or correlate them back to specific threat actors. So what is it that we do not want to do in this kind of context? And this is a little bit of a clarification, because folks have been concerned about duplication of efforts. There's always the N+1 problem with standards. We have N standards for a particular problem space, and then somebody else comes in and thinks they can really make it a lot better. And then there's the there's a new standard that is supposed to be consuming all the others, and ultimately you end up with N+1 standards. This is really not the idea for this project. What we want to make sure is that we identify some of the most important standards which are being used today for information sharing or threat sharing, and effectively enable semantic interoperability between those standards by clarifying what the semantic and conceptual relationships between those different standards are today. So the goal is really not to take over any kind of or centralize any kind of threat information sharing, but instead to develop the glue code that is necessary in order to be able to translate successfully, for example, from OpenIOC to STIX to NIM, and then ultimately to snort rules that could be deployed on machines. So the focus for this effort will then be the development of a meta model and semantic interoperability, so that we broaden the view and identify specific areas of improvement for each of the standards that are communicating. Ultimately, we really want to leverage the strength of the model-driven architecture that, of the object management group in order to bring that to this threat sharing environment. So what's the approach? I already talked briefly about a multi-phase approach that we are planning on having, starting with an initial mapping between existing concepts, namely between the STIX data model and the NIM UML profile, and then broadening that to a meta model that can encompass more and different protocol stacks, and not only STIX, and then ultimately include other non-cyber related domains. This will include the creation of a platform-independent model in the MDA sense, and then various platform-specific models that represent the different protocols that we want to integrate with. We also want to broaden that and see in how far existing social models of threat actors or threat actors in campaigns can be integrated in that. For example, as I was talking before, by using the SI-STAR framework. Ultimately, we want to make sure that we can also integrate with the NEAM 3.0, with a common alerting protocol, and other applicable systems that are used out there, and extend that to just the basic information sharing, but also include a countermeasure deployment, for example, similar to what STIX has been doing with the courses of action. So the first phase is going to create an initial cyber domain platform independent model using the UML profile for NEAM in order to model the STIX information exchange and effectively be able to create that independent model in a way that, on the one side, reproduces the artifacts that STIX has been producing in the past, while at the same time also enabling automatic generation of NEAM compliant schemas that represent the same kind of information. The expected output of this step is going to be a specification that includes, obviously, the cyber domain PIM, which will be consistent with the rules set forth in the UML model for NEAM, and on the other side, a cyber domain PISM that will map back to the STIX artifacts. The rationale for taking this approach is to it's fairly easy to achieve. We already have this, the STIX data model. We already have the NEAM UML profile. So the only thing we still need to build ultimately is the PIM and the STIX PISM itself, which is definitely quite achievable. In the second phase, we will broaden our approach and try to integrate then with other existing information sharing standards. For example, IOC. For example, IODEF. Maybe include SNORT rules. But also look at other existing UML and other models that have been working in this context as well. So I'm thinking about the CORAS model, which has been around for a while, or including some of the exorcism-based approaches that we have seen. Ultimately, the goal is here really to expand the existing work that we've generated in phase one, add new PISMs, and then probably also take this to create a higher level meta model that is encompassing of all of that and possibly more. For the third phase and so far final phase, as I said before, we wanted to expand this to include non-cyber related domains. Specifically, we wanted to look at use cases in the law enforcement context, defense, but also emergency preparedness. We are interested in developing a common threat ontology that includes those non-cyber related capabilities, and base that on this on the threat meta model that we developed in phase two. Ultimately, we really want to be able to arrive at those cross-domain functionalities in order to be able to describe really complex campaigns that often do not include cyber assets only, but also include all kind of other physical threats as well. Some of those areas could include, for example, supply chain risk management, digital forensics, and related efforts. Also in phase three, we want to ensure that we have full support for countermeasure modeling, which will allow us a consistent model for describing and deploying countermeasures and then map them to specific threats. That will ultimately enable the automatic mitigation and the automatic deployment of countermeasures to mitigate threats as they come up. So to summarize, the goals that we have is to enable conceptual interoperability or interoperability at the conceptual level of existing systems and really generate enough of a mapping to enable existing standards like STIX or OpenIOC or NEAM to have a full interoperability, not so much in a centralized kind of a model, but much more in a federated kind of a model. This would be achieved by using the model-driven architecture and generating a platform-independent model that then enables the creation of specific platform-specific models for each of those standards. We also want to ensure that we can include the enablement of automatic threat mitigation methods, as well as improve the overall attribution capabilities for existing environments by including social and behavioral aspects in this kind of a model. So the notional timeline, as it stands right now, is here. There are a couple of elements in this kind of in this timeline that I want to point out. We already started with the generation of the materials for the request for comment, for submitting that in the March timeframe to the object management group. And then ultimately, hopefully, have a spec ready for full submission by June of this year, finalize it through the end of the year. As we go along with that, the idea is to identify the necessary social modeling frameworks and other elements that we're going to need for the second phase, and prepare a RFP in the third quarter of this year, so that we can generate the meta model on the respective PISMs by the end of this year. For phase 3, which is still fairly notional, we are looking into identifying the respective stakeholders and reaching out to them in order to be able to define the right use cases that we're going to need in order to be able to broaden our approach to non-cyber related domains as well. So there's an email list where you can get more information about this project, and you can subscribe to it by sending a request to request@omg.org. We also created a couple of GitHub pages that will include all the material that we generate on the artifacts that we generate on that GitHub page, and will allow us to collaboratively work on that. With this, I would like to thank you for your participation and looking at this, and I would hope to see you on one of those next calls. Thank you.
Great. Thank you so much, Gerald. Just very quickly, I wanted to open the floor and see if there were any questions. All right. Looks like there aren't. Well, thank you very much for joining us.